Okay, let us solve this one from the first principle. Welcome to another tutorial mathematics, first year university. How do we differentiate this from the first principles? All right, so recall that the first principle formula is f prime is equal to the limit as h approaches 0, f of x plus h minus f of x over h. This is just for single variable functions like f of x. All right, so we can start evaluating from there. I think this can now be transformed into f of x, the same thing as if I transform this one, because this one is 1 over something, if I disprocate, it becomes to the negative power, meaning it's 2x plus 1 to the power negative half, isn't it? You agree by this nature, isn't it? Now, we can now start evaluating one by one. We can evaluate the first part from there. All right, so we can now evaluate f of x plus h, which will be, let's go. Yes, exactly. So here we are going to have 2x plus h plus 1 to the power negative half, which will give us 2x plus 2h plus 1, everything power negative half. This is what we need for f of x plus h. All right, f of x is already known, it's the same one. Then substituting them into this formula that we have. So now we are having 2x plus 2h plus 1 negative half minus 2x plus 1 negative half over h. This is what we have. Of course, limit as h approaches 0. That one is what we have. So after substituting, what comes next? With negative powers, to be quite difficult. So what we do is let's take them back to where it was. So I will eliminate the limit so that you know that we're doing the limit as h approaches 0. All right. So if I take them back into the way they were, this just becomes 1 over 2x plus 2h plus 1 root minus 1 over, then here I'm going to have 2x plus 1 over h. All right, so then from here I'll start evaluating one by one. Let me start evaluating by the if I want to evaluate this one, I can do the conjugate thing, you know, where you multiply the numerator and the denominator by the conjugate of that number. That's what we do, isn't it? Exactly. So or the way it is like this, I can first find the common denominator. All right, so I'll say my common denominator on top is just 2x plus 2h plus 1 square root multiplied by the square root of 2x plus 1, dividing this one into here to give me that one, to give me this 2x plus 1, and there's minus there, minus. Now I'm going to get this part here, 2x plus 2h plus 1. But remember, everything is being divided by what? H. We are moving. So now we have this situation, meaning we have this 2x plus 1 minus 2x plus 2h plus 1 root of the h will multiply this one, so this becomes h multiplied by, then we have the square root there. Everything is being multiplied, remember, so we can have a common square root where we have 2x plus 2h plus 1 multiplying 2x plus 1. Now we have reached somewhere where we know that, okay, we can work out something. Let's begin with the top part. Let's begin with the numerator. Let's evaluate the numerator. Of course, we know that our numerator is 2x plus 1 minus 2x plus 2h plus 1. So how do we evaluate this one? I think by now we know that we can multiply the numerator and the denominator by the conjugate of the same. So here's what I'm going to say. I can multiply 2x plus 1 minus 2x plus 2h plus 1 by the conjugate of the same, which is what? Root of 2x plus 1 plus. Now I've got 2x plus 2h plus 1. Even the down part by the what? the conjugate, which is 2x plus 1. I'm just getting what is there. 2x plus 2h plus 1. Okay, we are rationalizing the denominator or the numerator, whichever one that you are comfortable with. Please do go. All right, now simplifying this, because these are just the same, which means it's just the difference of two squares. All right, meaning we only have 2x plus 1 minus 2x plus 2h plus 1. That's a difference of two squares. So I've got this part and that part. Kwasila, you square them, you are still going to get this. In short, I'm saying this for someone who's not aware of what is happening. This is the difference of two squares. I think you can see there's a plus and minus there. So what we do is that if it's a difference of two squares, meaning we have this minus squared over 2x plus 1 square root plus 2x plus 2h plus 1. Meaning what we have here is just 2x plus 1 minus, there also have got 2x minus 2h minus 1. We have something like that. Meaning over 2x plus 1 minus 2x plus 2h plus 1. This will give us what? These gone. So we have negative 2h over root of 2x plus 1 minus 2x plus 2h plus 1, like that. This is our simplified numerator. Meaning from here, where we are here, the whole part here on top, we are just replacing this, what we found there, here. Meaning our function now becomes, our top part is going to have negative 2h over, remember that this is dividing, all right? This is dividing. Since it's dividing, it's going to multiply with this part here. This part is going to multiply our denominator. Meaning there's h there. There is also root of 2x plus 1 minus 2x plus 2h plus 1 root of, but everything here is multiplying. Okay, again we have this part here, 2x plus 2h, remember 2x plus 2h plus 1, everything, remember this is all this now is under the root. I think that's what we said. There are 2x plus 1, everything here is under the root. You are still multiplying them, so it's still just fine. So this is what we have. This is the situation at hand. So how further do we simplify it? All right, we can see this h and that h can cancel, so we have negative 2 on top, right? Good. Since we've got negative 2, can we fail to expand this? Recall that our h is approaching what? 0. So as h approaches 0, meaning if I put 0 there, I put 0 there, what does this become? That's where we need to go now. All right, what does this become? This becomes negative 2, and that one will give me square root of 2x plus 1 minus, this just becomes the square root of 2x plus 1 multiplying it. Yeah, so we have 2x plus 1, sorry, 2x plus 2, no, 1, then 2x plus 1, everything, but everything is under the root. Here it's plus, not minus, plus. I hope you saw this mistake, by the way, because you saw that if these were giving us 0 and we can't have negative 2 over 0, that could have been a problem. Can't here we made a mistake. Instead we copied the correct thing, but now we maintain the negative. I don't know where the negative was coming from. Pardon me on that one. All right, now meaning that what do we have now here? All right, this, if we multiply this, what are we getting? We're just getting the same. All right, just getting the same. And here we're adding, which is 2 of this. So we have negative 2 over 2 of these 2x plus 1 is multiplying. If I multiply this one, I'm just going to get 2x plus 1. I'm just squaring them. Now, two and that give us -1 over. This part here inside is the same thing as 2x plus 1 power half. You agree, right? Then this is the same thing as 2x plus 1 power 1. Same basis, we add the powers, so -1 over, this becomes 2x plus 1. 1 half plus 1, this becomes 3 over 2. Therefore, the derivative of that friend of ours is just this, 2x plus 1 to the power 3 over 2. Done. Next question. Evaluate the limit as x approaches infinity for 2 minus 3x minus 5x squared over 1 plus 2x squared. How do we evaluate the limit? Step 1. If you see this type of arrangement, what arrangement? If you see that we have a common degree in the polynomial, all right, or in the two polynomials or three, you divide by that common highest power. So you divide by the highest power, meaning every term here must be divided by the highest power, meaning we have the limit as x approaches infinity. This becomes 2 over x to the power 2 minus 3x over x power 2 minus 5x squared over x squared over 1 over x squared plus 2x squared over x squared. This is what we do. Meaning the limit as x approaches infinity becomes 2 over x squared minus this becomes 3 over x minus 5 there over 1 over x squared plus this becomes 2. Now, if I substitute infinity here, so if I said 2 over infinity squared, just the same thing as infinity, don't even have to repeat it, over infinity minus 5 over 1 over infinity plus 2. If I divide the number over infinity, that number will keep on approaching 0, 0, 0, 0, 0. Meaning here we just got 0 minus 5 over 0 plus 2, which will give us -5 over 2. Therefore, you say now the limit as x approaches infinity for which one? The same friend of ours. You rewrite it over 1 plus 2x squared is just equal to -5 over 2. You don't even have to waste time there. Given that the f of x is equal to x squared cos x, how do we find the derivative of pi over 4 of f of x? Step 1, find the derivative of f of x. This is a cosine, and by the way, come on, this is just the product rule. We've got x squared and cos x. It's the product rule. The product rule tells us what? Differentiate, keep constant. Then keep constant, differentiate. You know what I mean. You've got u, our u will be x squared, our v will be cos x. Meaning you need to find the du. Du is just 2x dx, and the dv is what's the derivative of cos? It's negative sine x dx. That's all. Okay, done. Meaning f prime of x, first of all, is just equal to uv. We know by now that it's v du or whatever it is, whichever you start with it, please, you feel free, you are comfortable. All right, so we are going to have v du plus u dv. So v du is just 2x cos x. Now we have x squared sine x. This is the prime. Now at pi over 4, now evaluate that at pi over 4. So now this at pi over 4 is just 90. You get the concept, right? So we have 2 multiplied by pi over 4 Then we've got cosine pi over 4 minus pi over 4 squared, then sine pi over 4. Let's go. This gives us pi over 2. What is cosine pi over? It's the same thing as sine pi. Sine 90 and cos 90, I think by now you know that it's the same thing. It's root 2 over 2. Root 2 over 2. Or if you want, you can say 1 over root 2. The answer is still the same. This becomes pi squared over 16, open brackets. You are still getting the same root 2 over 2. And of course, we are getting root 2, then pi over 4. I'm just expanding, by the way. Then you have root 2, then pi squared over 2, and 16, we get 32. Done. Kwa maana